side by side three main protocols. One is without coding. This is my baseline. This is what's happening right now, saying something like Ethereum with libp2p, source forwards original shards directly, and the duplicates pile up really fast. Nodes have to become therefore selective about which peers they listen to so that they don't basically drown under duplicates. And then there's limited forward movement of the data to avoid that drowning, and that limited forward movement of the data is itself deleterious and something that we didn't really want. Reed-Solomon is a middle ground that's using a system that was developed for an entirely different approach, way before I was born. And there, the source encodes a message into 64 shards, and any 32 of those suffice to actually do the reconstruction. So more rival state useful. And at first it would seem like, okay, this is going to really manage the issue of the overlap or the duplication. But it turns out that it's really limited by the fact that you have to make that assignment of 32 to 64 shards in a really static fashion. And so particularly as the network grows, that becomes actually almost as bad as without coding. So it's not as bad as without coding, but it really is inherently having the same limitations as without coding. The last one, random linear network coding, which I'm co-inventor of, as I mentioned earlier, is the one I really want you to focus on. That one is built for this kind of networks. It's not built, a lifetime ago for something completely different. This is built basically with these decentralized systems in mind and is optimum for these decentralized systems. What happens here is you have these shards from different peers that are not just coded at the source, like with Reed-Solomon, but are being recoded as we go along so that the inbound bandwidth is always staying productive.